All right, guys, let's try some examples. So we're going to start with f of x equals negative 2 plus sine x. The thing that I hope you see here is this can be rewritten to look like the general formula I gave you earlier, sine x plus a negative 2. Or you should be able to see that this is sine x minus 2. So this is the formula that you'll see A, B, C, and D. All right, so from here, you should be able to see the number in front of sine. The number multiplied to sine is A. A is equal to 1. The number multiplied to the x is a 1. The number added or subtracted in parentheses to x is 0. And then the number added or subtracted to sine is negative 2. So the amplitude is 1. The period length is 2 pi divided by 1, which is just 2 pi again. And then the phase shift is nothing horizontal, but we're going to go down 2. And down 2 means our axis is negative 2. So when you set your graph up, your axis is going to be at this negative 2. Value of y. Remember I told you that the amplitude goes above and below the axis. So the amplitude is shown here at negative 1 and then negative 3. And then we mark the furthest to the right is going to be C plus the period length. So 0 plus 2 pi again is 2 pi. And then marking the intervals across is halfway is pi, 1/4 of the way is pi over 2, and 3/4 of the way is 3 pi over 2. So we got the graph set up. We're looking at a sine function, and sine begins with a point at the beginning on the axis. It goes up to a maximum. Halfway across the graph is on the axis, down to a minimum, and then ends at 2 pi on the axis. When you connect the points with a curve, there's your graph of negative 2 plus sine x. All right, so a more difficult example. Y equals 2 times cosine pi x minus 3. Are there any parentheses around the x? So C is 0. The number in front of cosine is 2, so A is 2. B is pi. Ridiculous. And D is negative 3. Okay, from here you should be able to see the amplitude is 2. The period is 2 pi divided by pi, which means the period is just 2. The pi's cancel out whenever you divide pi by pi. Pi by pi. And then the phase shift, we're not going left and right any yet because C is still 0, but we are going to go down 3. And again, the axis is negative 3. All right, guys, so I got the axis marked here, and the amplitude is 2 above that axis and 2 below that axis point. So 2 above negative 3 is negative 1. 2 below negative 3 is negative 5. And our period is 2. So the furthest to the right that I'm going to mark is the period plus C, which is 2 plus 0, which I'm going to mark it up here on the x-axis, which is 2. halfway between 0 and 2 is 1. And then the halfway points there are 0.5 and 1.5. Now you can mark them on the dotted line. That's not going to affect anything. It might even help you with drawing it neater and stuff. But where you mark it is up to you. All right. So we're talking about cosine. Cosine has a point at the maximum at the beginning. And then 1/4 of the way on the axis, a minimum halfway. Axis 1/4 of the way. And maximum at the end. Connecting those points looks something like this. And because we're given this graph, it looks like it's symmetric on both sides. We could actually show 2 period lengths, and there's going to be a time where I'm going to ask for showing 2 period lengths of either a sine or cosine function. And that's doing the exact same pattern, just going backwards. Because these functions continue on in both directions, left and right. They continue on forever. Here we have y equals 3 cosine pi over 6x minus 3 in parentheses plus 4. So here we should be able to see A, B, C, and D pretty easily. A is 3. B is pi over 6. C is actually a positive 3. C is the opposite of whatever is in parentheses. And then D is 4. This then tells you your amplitude, your period, and your phase shift. Your amplitude is 3. Your period length is 2 pi divided by 6. And whenever you divide by a fraction, you actually multiply by its reciprocal. So it's 2 pi times 6 over pi. The pi's will cancel, which means 2 times 6 is equal to 12. So the period length here is 12. And then the phase shift is right 3 and down, up 4. All right, remember, when you draw your graph, start with your axis and amplitude. Your axis is your phase shift going up or down, which is 4. And then your amplitude is 3 above that and 3 below that, so 7 and 1. The thing that's probably most difficult about labeling this graph is your period length and your phase shift to the right or left is going to come into play here. So if we take the phase shift plus the period length, then that means the furthest that I mark out on the x-axis is 15. Because I have got to start from here and go to the right 3. And you should see here the difference between 3 and 15 is 12. Which is the period length. This is probably going to be one of the most difficult ones. And then you label your intervals halfway between 3 and 15 is 9. Halfway between 3 and 9 is 6. And halfway between 9 and 15 is 12. So there's your intervals. And now we're using the cosine function, so we're following that pattern of critical points, which is maximum, axis, minimum, axis, maximum. All right, so this last example here includes a being negative. Negative 2 cosine pi over 2 x. So a is negative 2, c is 0, D is 0, and B is pi over 2. This tells us the amplitude is 2. Its amplitude is always going to be positive, but the negative for A tells us that the graph flips, which means maximums become minimums, minimums become maximums in our little pattern that we established at the beginning of class. The period length is 2 pi divided by pi over 2. You'll see that this is a 4. 2 pi divided by pi over 2 is 4. And in the phase shift, there is no phase shift. So we're going to start on the y-axis and the x-axis. So when we graph, our axis is at 0. Our axis of rotation is at 0. Our amplitude is at 2 and negative 2. And our furthest point out to the right is 4. And then you should be able to see half of 4 is 2. Halfway between 0 and 2 is 1. Halfway between 2 and 4 is 3. The pattern, because it's negative, becomes minimum axis, maximum axis, minimum. And this is what it looks like when the graph flips. All right, guys, that's periodic functions.